Welcome to this introductory session on the SAP Cloud Application Programming Model. In this unit, we're going to look at basically what is the SAP Cloud Application Programming Model and why did SAP go about creating it. There's probably no better place to start than right here at cap.cloud.sap. This is the homepage on the internet for all things related to the SAP Cloud Application Programming Model. And it's a great place to get started in your learning, where you can find all the latest information as far as release notes and change logs, sample code or links to sample code, links to blogs, blog posts, and a whole wealth of documentation on the subject of the Cloud Application Programming Model. But actually, we want to go back in time just a little bit to the beginning introduction of the Cloud Application Programming Model. And this is a blog post by Daniel Hutzel, the lead architect of the Cloud Application Programming Model, where he did an excellent job explaining the background as to why SAP even set out to create this new programming model. And just to summarize a little bit here, as we have a rich history at SAP going back to the ABAP development world, and honestly, the roots of the concepts in the Cloud Application Programming Model have a very close tie to ABAP. We looked at what was so valuable about ABAP in the ERP and now the S4 application environment. And it was really the fact that everything about ABAP is designed so that the application developer can focus on their domain issues and solving problems for their business, but not spend so much time in the underlying technology to implement that. And honestly, as we begin developing cloud native applications, so those kinds of applications that we can't or choose not to build using the ABAP development environment and runtime, but target to take advantage of cloud elasticity and microservice architecture that utilize programming languages like Node.js and JavaScript and Java. We have the same core problem here, that we want to have an environment that allows business application developers to focus on their business problems and how to solve those in their code and not have to spend so much time on the low-level technology. In this environment, it means things like how do I create services that have full create, read, update, and delete operations in them? How do I deal with standards on service enablement and message brokering? How do I deal with common technology problems that are related to the business in our enterprise world, like localization, like multi-language support, currency conversions, unit of measures, all these things that we expect a enterprise application development environment to solve, but are probably not there in core language runtimes to solve most of these problems. Or if there is something there, maybe we have to drop too low level into the infrastructure to do that. And that's what led SAP to devise the Cloud Application Programming Model, and to really focus on solving those problems in a way that that brings some of those same benefits to bear, but does it in a very cloud native kind of way, so that we're not having to create a whole new runtime. We want to be able to plug into the existing open runtimes of Java and JavaScript or Node.js, but bring some of those best practice concepts from the ABAP development environment into this world as well. So what are some of the major areas of focus of the Cloud Application Programming Model? Once again, we'll have a look at Daniel Hutzel's blog post here that does a good job of laying out the major parts, and let's talk about them each in some detail. First of all, one of the major things that we wanted to make possible with the Cloud Application Programming Model was give you a way to easily define and build your data model. And for this, we leverage the CDS, Core Data Services syntax. And you may already be familiar with the concept of CDS. It's something that is the roots of which go back to early days of HANA development, where we first introduced the CDS syntax via the HDB DD artifact, going all the way back to, I believe, HANA 1.0 SPS 6 was when we first started making that possible. And in the ABAP development environment, we also have core data services as well. Now, the basic concept of core data services is to abstract that data modeling or service modeling that we do in our application and provide a common syntax to be able to do that. Now, the use cases of core data services obviously vary a little bit from its usage in the cloud application programming model to its traditional usage before in HANA development to how it's used in the ABAP development environment. Here in the cloud application programming model, it's first used for all of your basic data modeling. We can use it to define our tables, views, the relationships between those things, reusable types, abstract entities. The full range of data modeling is available and possible here using the cloud application programming model. And the generic framework takes care of then compiling that to database artifacts that can be automatically deployed to SAP HANA. So this is now our main entry point into doing most of our design time based data modeling in the HANA development environment as well. Now, furthermore, the cloud application programming model also allows us to define our services and do it in a rather abstract way there as well, rather than strictly tying us to a particular service technology, whether that might be OData or plain REST services or whatever else might come along in the future. We're able to define our services in a very agnostic, technology delivery agnostic way, once again using the core data services syntax. And the cloud application programming model framework will take care of translating that today into OData service definitions, but also we begin to see support for plain REST services and how in the future we could add other service technology endpoints. It does all that serving out of the box without you having to build service technology or implementing the create, read, update, delete operations yourself. It has syntax to be able to handle authorizations and input validations, auditing information, tracing, all the basic fundamentals that you don't want to code over and over again. And often if you're building your own services from scratch, you might build and then cut and paste or build a reusable library for. Here SAP has delivered all those kinds of capabilities built into the generic service framework. But at the same time, you're not locked into only what the cloud application programming model provides you when it comes to service enablement. We also have the ability to add our own custom logic to either enhance the existing events that are processed by the generic service framework in either sort of before or after kind of event handlers where we can further augment or do additional validation. Or we can completely override the generic service handlers and provide our own custom implementation. And here we have the choice of either using Java or Node.js development approaches. Next, we also have a focus on Fiori UIs. And once again, we can use core data services and specifically the annotation concepts of core data services to build the extra OData, the additional metadata that will be translated into OData vocabularies, which in turn drive the Fiori elements kinds of applications and allows us to generate those UI applications without having to do much, if any, client-side UI development, and instead define our definition, define our UI definitions using annotations as either part of our data model or as an additional layer on top of our data model. The other major aspect that this is the part that maybe gets lost in the shuffle a little bit. We focus on the data modeling and creating new services, but you're hardly ever working in a complete vacuum and creating your whole application from scratch. Often we need to connect to and reuse existing services. This is particularly useful in scenarios where you're doing side-by-side extensibility of an existing application. And here we have the built-in capability to consume these other services, but also include them in our own services and do mashups, taking the existing standard service and then maybe adding, our own extensions to the data model where our data is persisted separately from the core application. So instead of, in the case of, say, S4 development, instead of going directly into the S4 system and extending the SAP delivered data model and then adding our own custom logic in ABAP, we have the ability to come here and do a side-by-side extensibility where we take the standard service, we wrap it using the Cloud SDK that's built into the Cloud Application Programming Model. So we're proxying a call through to the underlying standard service, and then able to model our own semantics, add additional semantics such as additional fields, additional UI capabilities, and then deliver our own new custom service that is, once again, a mashup of the standard service plus those new elements that we've created, and do this in either Java or Node.js. And we've also seen recent enhancements in the Cloud Application Programming Model where it's not just about calling existing, say, OData services, but also interacting via messaging and being able to both raise and subscribe to messages in order to have another way of doing extensibility and data interaction with other standard SAP applications. But these key capabilities that we've described about the Cloud Application Programming Model, we have to keep in mind that, once again, SAP isn't trying to create a complete runtime environment here or something separate from what you might already know in the cloud native world. Instead, we're focusing on a couple of key points and enhancements that we can then plug into standard environments. So for instance, we start with the core runtimes of Node.js with Express, or Java with Spring and Spring Boot, and we don't try to reinvent those core components. Instead, we've created libraries and modules that plug in seamlessly into those existing environments. It doesn't cut you off from the core capabilities of those environments either. You can still drop down into the lower level coding capabilities of Node.js or Java, Express, and Spring when you need to. But we've created an agnostic runtime that works the same way largely in both of those environments to allow you to choose as a developer which one you're more comfortable utilizing. At the same time, we're trying to be very open with our development tooling. We have Cloud Application Programming Model development tooling designed to work in Visual Studio Code, to work in the Business Application Studio, to work in the SAP Web IDE for SAP HANA, or you could do your complete development cycle from the command line with a basic text editor, because the core component of doing development, the CDS, is a command line interface at its heart and soul, and you can get to almost all the functionality you would need to create and deploy your projects simply with only having access to the command line. The focus, as we've described in the previous capabilities, are on delivering the core data services, CDS functionality that gives us our data modeling, our service definition, and our UI modeling through annotations, and then a set of service SDKs for both consuming external services and exposing our data model as services as well. But that's really where the delivery of Cloud Application Programming Model ends. From there, we rely on standard database concepts from SAP HANA for actually performing the persistence and much of the processing in the persistence layer. CDS compiles the definitions that you model into native artifacts that SAP HANA understands. And likewise, we generate the annotations that are in turn interpreted and driven by SAP Fiori applications. We don't generate UI applications directly out of the Cloud Application Programming Model either. And all this is also designed to run on different cloud infrastructures. Yes, most of the SAP examples are certainly shown on the SAP Cloud Platform, and more specifically in the multi-cloud environment, the Cloud Foundry runtime. But I've personally done Cloud Application Programming Model development and deployed it using Docker onto Kubernetes and the Kima runtime as well. There's very little differences, if any, well, really no difference in the coding that you need to do, only a little difference in the way that we package the application and create the deployment descriptors. So we have a technology that can run in a variety of different infrastructures. And it's through this design approach that SAP is really able to achieve a very agnostic approach, which in the end safeguards your investments. We avoid lock-in to any particular technology or any particular protocol by working in this abstracted layer. We can define our services and allow over time the actual technology to deliver those services might change, for instance. Today we're very focused on OData, OData v4, but we see the ability to take from the same service definition and data model also generate REST services, and in the future GraphQL as well. Likewise, when it comes to messaging exchange in the Cloud Application Programming Model, we offer different technology options there, focusing now on enterprise messaging and MQ, but in the future Kafka as well. By the same token, when we work with our data model and the interaction with the persistence layer, yes, today there's very much a focus on HANA as the primary persistence that we generate, but everything is designed in a way to not allow too much database-specific functionality, to once again provide a bit of an abstraction layer, so the possibility to also support different database technologies through the Cloud Application Programming Model in the future as well. So Cloud Application Programming Model really attempts to be both very open in its technology approaches, as we've seen, yet at the same time opinionated. So we don't want so many options that the individual application developer, particularly the business application developer, has to make all kinds of low-level technology decisions. We want things like how to do logging, how to do auditing, how to connect to the database. We want those best practices to be provided by SAP in a very consistent way. So when I just want to focus on creating my business logic, I don't have to reinvent the wheel, so to speak, and always come up with those low-level approaches, or always go find some third-party library to be able to do those things for me. Cloud Application Programming Model makes many of those lower-level architectural decisions for you, but in a way that doesn't lock you into only those decisions. There's many places where you have the ability to break out of what the Cloud Application Programming Model suggests as its approach. That's why we call it opinionated. Instead of simply making all the decisions for you and then locking you into them, it offers a educated, experienced opinion about how things should be built. For instance, we have the out-of-the-box support for SAP Fiori. We have the ability to, through the annotation support, really heavily provide a good and easy to use SAP Fiori development experience. But at the same time, we are absolutely not locked into only SAP Fiori or SAP UI5. We see the cloud application programming model being used with other UI technologies just as easily. We also see the openness, as we've talked about, on different service broker technologies, how we aren't locked into a particular service delivery technology. Yes, there's a heavy focus on OData v4 because that is the main service technology used by the business applications at SAP, but we aren't locked into only that technology. From the same service definitions, we can also generate other service technologies as well. And finally, a very, very open when it comes to how you want to do your application development, whether that's the SAP Business Application Studio, Visual Studio Code, Eclipse, or, as we said before, through the command line interface, whatever IDE you choose to use, even if that is just a plain text editor. This allows the cloud application programming model to really focus on a few key parts of application development, as we've described: building your base domain models, your data model itself, which generates into your persistence layer or your data sources, to defining your service interfaces, and then not doing the complete UI building. We're not describing every aspect of the user interface, but through UI markup using the annotations, able to do a high-level description or first-level design of your user interface as well. I hope that you've enjoyed this introductory look at the SAP Cloud Application Programming Model, some of the history and the reasons why SAP has built this programming model, and the main design goals and value that it brings to your development environment. Now, this is just the tip of the iceberg. I hope that you continue on with us in the rest of the units, where we will really look at how we build applications using the Cloud Application Programming Model, which will allow us to see its interaction with the development tools, the debugging environment, how we deploy applications, but also go really in depth into the modeling syntax, the service enablement, the exiting process that we talked about, where we can add our own custom logic. And it's really through building such an application with the Cloud Application Programming Model, through the set of exercises in the subsequent units, you get hopefully a very excellent view of the full scope and range of capabilities that the Cloud Application Programming Model brings to your ability to build SAP business applications.